Okay, it's 2 o'clock. Let's do it. Today we're going to think about a few finishing touches for our tub. First thing I want us to do is check out our canvases and just kind of see where we're at. I'm going to open my name views, go to our left front, and I'm going to hide the tub just so we can get a better picture of what's going on. Okay. There we go. So one thing I'm thinking about is this softened edge. It's really an aesthetic detail, but I want us to think about ways we can do that. And there's not a lot of detail here. I think there's some room for interpretation. And then what we're also going to think about is the function of our tub. This is going to be filled with water. Even if it's cast iron, it seems a little dubious, especially as we start to work on kind of the aesthetics of these walls. We're going to remove some material here probably. So rather than thickening things, we also want to think about how we can use a little bit of material and then brace this. Now, that might be overkill. Tubs probably aren't necessarily like this. But if you're thinking about kind of hollow, thin-walled projects, it's a feature we can play with, and we'll have like a very robust cast iron tub. And we'll do some filleting, finish that side out, finish the top side, just make sure everything's looking how we want it. And then we're going to talk more about joints. So mechanical joints that we really we want to focus on at least are our handles, maybe the stopper. I went ahead and finished the stopper after we parted ways last time. We ended about here. And I just made a simple revolve based on just kind of looking at a stopper. There's a little hand grip there. Pretending that this is the gasket, like the rubber part that compresses down. Nothing super realistic. I made them all one body. So not a big deal. We could change that material. Maybe we could make that like, just apply that to the face. Doesn't want to do that very well. Well, another reason we could separate it into its own body. We'll go back to our brushed. That's fine. We can pretend it's a gasket, or you could make it its own body or its own component. When we do joints too, we're going to talk a little bit about how we can maybe simplify our browser tree here. We've got so many different pieces. It might be helpful to have a way to kind of organize it, especially these McMaster components we imported are these just part numbers, which is meaningful if we were to go reference those back in the McMaster catalog when if we were purchasing these parts. But as far as like the design of this thing, it's really hard to remember. Is that a nut? Is that a bolt? What is that? Which bolt is it? Those kind of things. Rather than renaming it, we're going to place it closer to its assembly. We're going to think about like this whole group here when we work on the tap handle as a sub-assembly to the assembly of the whole tub. So let's get started. Let's open up our canvases, go to a view where you can see this kind of swirly shape. If the tub's obscuring it, I forgot my, every time. Where the tub's obscuring it, you can hide it. In fact, we might want to hide many things right now. So all of pretty much everything. We're probably going to be cycling on and off the tub body as we start to carve into this. But right now, we just want to kind of think about what we need to do. I'm looking at this, and it's kind of a wave-like pattern. It starts low, it kind of wiggles, and it gets a little higher up on this side. So let's start with a sketch and just kind of sketch this out, feel what it's going to look like. And then maybe we can think about ways we can turn that into a feature. Just want to make sure my typing is working. Great. So we can keep our canvases on. We're going to need them in a second. I brought the tub body back so we can see it because we want to create a sketch on this face. So create sketch, click on the face of the tub. I'm going to immediately hide the tub because it's blocking so much of our canvas as it protrudes through. So I'm going to start with a fit point spline rather than a control point spline. Just to review, control point spline gives us slightly different options. We want the abilities that fit point spline can do. Spline, excuse me. Again, I'm going to try to shoot for as few points as possible, if I can. And then rather than trying to remember if it's enter or escape to end that line, I'm going to have it just pressing that check mark because I don't want to confuse y'all. And then when we finish the spline and it is sitting there, we can definitely hit escape to end that command because we're done with it. Okay, next thing I want to do is I'm going to draw a rectangle just kind of around our spline. And then I'm going to make the ends of the spline coincident to these walls, or these ends, not walls yet. So make sure I have nothing selected. Coincident, this point, that line, this point, that line. Depending on what you select first, one piece might move to the other piece. Sometimes it's kind of little decisions are made without us knowing sometimes. Now we want to try to avoid sharp curves. I'm not going to worry too much yet about if our sketch is tangent, meaning if this spline flows perfectly into that rectangle. It'd probably be a nice thing. We can go ahead and try it. This is an example of if we think about what tangency means. Right now, this spline is intersecting, or about to intersect, this vertical, and it could either be tangent this direction or this direction. So if you're kind of on one side or the other, if we hit escape, have nothing selected, and we click tangent, click on the spline, click on the line, it's probably going to want to dive that way, and then we're getting this sharp corner because we're thinking about this part of the profile as the part of interest. So if you're getting that problem, it's probably best to position it close to how you want it, and then do that command, and then it's going to go tangent the other way. Now let's say you do have your spline up like this, and you make it tangent. Can you fix it? You could delete that. Say you didn't notice it at first and you come back. You could always come and hunt for the little icon. Just be really careful where you click on it, make sure you're not clicking on anything else. And then you could hit delete to release that. Or maybe if we click on the endpoint there, you can grab this handle and we can slide it down the other way. So you're not in the weeds necessarily. So this is open to some interpretation. This is probably an opportunity to just try some things out. Nothing is really sacred here as far as what's right or wrong. This is an aesthetic part of the whole thing is not going to necessarily be perfect as we've seen with the rest of the project, but maybe we figure that out. It's going to be still kind of a tight turn, so maybe we push this over some more. Bring that up. Maybe this comes out some more. I'm trying to see kind of where that shadow rests. I'm not going to worry too much about this edge being symmetric to this edge. This might not be a symmetric feature. I mean, it already is this kind of amorphous wiggly bit. So if this side, say the distance between here and the end of the tub, and the distance between here and the end of the tub aren't the same, I'm not going to worry about it. You could make those even if you want, but I think it's okay. You could also further constrain this sketch if you so desired. Speaking of which, let's think about where these lines, what we're really thinking about, what we really want to accomplish here. This top part is going to be our profile, but we're going to see too, we're also going to need a bit that extends above. So really we're interested in both of these. And because we were building this on the side of our tub, we're getting this profile built in, this top edge or this bottom edge of the fillet. We're getting that profile built in because it's kind of just grabbing that because it's the construction plane we used was the side of the tub, so it's going to use what available edges it has. So we'll have these two. The height of this isn't super critical, but we want to make sure it's above this to some degree. I'm just going to give it some dimension. Now this bottom edge, this is going to be a reference tool. This is going to be kind of our pivot point, the way we're going to end up extruding this out. We want this to be clearly kind of identifying how far we are when we make our pivot. We're going to think about it in another direction. So we could, let's see if Fusion will let us do a tangency command. I think it won't between these two, this spline and this line, because they're not sharing any points right now. The problem with that, with asking Fusion to make this tangent to this, is that there's so many options right now. Because this is a fluid spline with all these different kind of points, it's not really like regular. It's not a repeating pattern. Fusion can't decide, do you mean tangent to here or tangent to here or here, anywhere along this. So we would need some kind of connection to that line to limit that. I like the way that looks. I'm going to keep that line just kind of where the lowest part of our spline drops to. And I'm editing all of this in this kind of isometric view that we grabbed for our name view, just because I want it to reference the picture. Let's go ahead and finish that sketch. And let's label it, because we're going to be jumping between sketches a lot. Let's call this calling it vertical, because right now it's just on that vertical plane. We're going to tilt it over in a bit. Let's make a new construction plane. So what I want is a parametric plane, meaning it's going to reference actual features, not just fixed dimensions or arbitrary placements. We're going to make a reference plane. We've done this before, but we're going to do a new bent plane between the inside wall of the tub and the outside wall of the tub. This is going to make sure we don't cut too far into the wall of our tub. And if we change that thickness later, it will adjust automatically. So we're going to start with a midplane, construct midplane. You can click in any order on the inside and the outside of the tub, and there's our midplane. If we look at it closely, we can see it's dividing even that fillet in half. Great. We're going to hit OK. And now we're going to start a sketch on that plane. So you can either click on it first, pre-select, or if you go up to create sketch or click sketch, then we can select that plane. Just make sure you are hovering somewhere over that orange bit. That's another reason why I like creating a midplane, even when it seems like you don't need it. Here we needed it, but it gives us like a nice kind of ability to grab at the edges and not have to kind of guess, are we clicking that plane or that plane? So now we're sketching kind of inside of that wall. Let's look down the side of our sketch and let's change this to wireframe. So I'm going to project this bottom line. I'm going to hit P on the keyboard and hit OK. And now we've got this point. Okay, remember I said this was going to be a pivot. This is going to be making sure that the furthest our extrusion, our cut goes, is to that depth. And then what I'm going to do is to make sure we end up with a nice blend into this top fillet. We're not going to cut into it, and we're not going to cut too far where it's a sharp edge. We're avoiding sharp edges. I'm going to start a line command, starting on that point, and I'm going to come find, oh, I'm doing this in the wrong order. Okay, we'll come back to this sketch. So what we should have done, let's roll back a little bit. Yeah, we don't need that sketch. Let's see, what was the midplane for? Did this afternoon trying to just retrace my steps. Okay, right. Midplane's supposed to go the other way, excuse me. So let's double click on that. And instead of those outside inside edge, let's make a midplane. We could go ahead and use the origin, but as I said, let's just make a midplane so it's clear. I'm going to call it short midplane, and I'm going to call this one okay. Make sure that's visible. We'll need it. Okay. Let's start a sketch here. And now we do need to think about the wall thickness, but we're going to think about it in a slightly different way. So let's go back to visual style wireframe. We want to find out what the center line is here. We're looking down the side now because we're eventually going to create an angle that looks something like this. Okay, I'm kind of just exaggerating it right now. It's not precise, but we'll work on that. So I'm just going to delete that. We don't need that line yet. What we need to find out is we're going to do something similar to what we did with that midplane. We're going to look at this inside and outside edge. I'll go back to shaded mode. So I'm going to project some geometry, hit P on the keyboard. I'm going to grab the inside wall and the outside wall, like what we did with the midplane, but different, and hit OK. I'm going to go back to wireframe, look down the side. That looks right. And what I want to do now is I'm going to draw a little tiny line between these two. So now we've established this thickness. And I'm going to draw a center line. And if you don't see that constraint, what I'm doing is I'm starting a new line by pressing L. And I'm going to hover over near that midpoint until it snaps. I get that triangle constraint built in. Okay, I'm going to draw that somewhere up near the top. Doesn't have to be really too far. We can constrain it in a moment. And I'm going to make everything I just drew construction geometry. Okay, if you're getting kind of, if it's looking muddy with that tub, we can hide it because we've got all the information we need from the tub. And let's make everything here construction by just with a marquee, grabbing it all and click construction. Okay, this is going to be unconstrained for the moment. But what we're going to do now is find where this point and this point will meet. So this point is the bottom of our rectangle that we drew as a boundary. So we can hit P on the keyboard and select that bottom line, hit OK. It's just going to give us a point where that intersects our verticals, the outside wall. And let's draw a line between those two. So what we're about to constrain is that height. So projecting that just into the center of this tub so we know where to start in our up and down. And let's make this horizontal vertical, or you could make it perpendicular. Show you that again. We could make this line horizontal vertical. I like perpendicular because it's really talking about the drawing itself, not so much relationship to like the origin or what's up or what's down. And let's make this also construction. So either hit construction, select it, construction. Looks like you have to select it first. Okay, now we just connect the dots. We're looking for the connection between this point and all the way up here. This point, this is if we bring our tub back, this is where we want that cut to pass through, to pass beyond. So let's do that. Let's create a new line. You can start either direction, 1 and 2. If for some reason you're still, looks like I'm still in construction mode, we can hit escape, select that line, and just hit construction again. It'll switch it to feature geometry. Okay, so all of that was to create a plane. We're going to create an angled plane based on that sketch. So if you want to, you could go back to Visual Style, Shaded, or Control-6 on the keyboard. Okay, we've got two sketches visible. This is our angled sketch, and then our profile that we're going to cut out eventually. So to construction, plane at angle, and we're going to find that line that we just drew that connect the dot line. And we want to make sure that angle is set to 0 degrees because we want to reference that angle and nothing else. So that angle is really just determined by the length here, this leg of the triangle, and then the center, this leg of the triangle from the tip to where the bottom of our spline ends, and then to the center of the thickness of the tub, which is parametric. So if we scale it, it should scale like I was talking about with the midplane. We did something kind of similar here. So it's parametric. We're always looking for ways where we can tie things to the meaning of the drawing. Okay, we have a new construction plane. We want to take this construction plane and project our sketch on it. Before we do, let's just look and see kind of what we already have. We kind of want this to go halfway through. So we know that's just because I remember we can do 5/8 divided by 2 halfway through, and then make that negative, so we're cutting. So right now with no angle, kind of looks like that. So we've got all these sharp edges. We could fillet that, of course, but we've got just kind of extra kind of bits. Even if we fillet that, just if we want to look at that. Okay, I think that's not maybe the most sightly thing we could accomplish. Like this, just, I don't know, something about it also doesn't seem as hygienic. We kind of want, if water, this is probably going to get wet, we don't want water to like collect underneath here or condensate. Just thinking out loud. So we're going to project that at an angle. So anything that drains will just drain straight off and not hang underneath the lip, avoiding a lip. So let's undo that extrude, or just delete it rather. And since we have our angled plane, let's bring our construction plane back. We're going to create a new sketch. Click on that plane. And then we're going to make sure we can see our side cutout vertical. And let's project it. So we can hit P on the keyboard, or you can go to Create, Project Include. And I'm going to take this part, and this part, and this part. We don't need that bottom edge. We could have made that construction geometry. That probably would have communicated that. But there we've got our profile. And we can hit OK. And we can finish that sketch. So let's clean things up a little bit. I've got my cutout angle plane. You can hide that. Our side cutout vertical, we can hide that. Now we've got side cutout angle. And if we look at it, it should give us kind of a preview of what's going on. So we're really only taking a sliver away. Let's go ahead and do it. So start with an extrude command, and just click that handle and you can pull it out anywhere. Now, we can't really get a good parametric extent here if we make this to 2 object. I haven't had luck with having it go outside, even if I change the chain faces command. So you're just gonna have to think about distance and just make sure it goes far enough. Okay, you don't want it too short. So I'm just coming up with a dimension. 1 inch will probably always be okay for however much we change that wall thickness, where it's never gonna be thicker than that. Okay, and there that is. That's kind of a little more elegant of a shape. Now, we'll be talking about water collecting. And sharp edges, we want to remove that. So right now we've got this sharp edge here and this sharp edge. We also want this corner to blend nicely. Before we do that, we want to think about, from our canvases, this has got that feature on both sides, which maybe isn't realistic for the tub. But maybe it gives you an option to orient it left or right facing. So let's pattern that. We can mirror it, but I want to try something new, kind of thinking outside the box. as far as, so a way to kind of mix it up. We could mirror this and it would just be perfectly identical. This side would be on here and this shorter side would be over here. Let's try something else. So let's go to circular pattern. If you don't see that up here, yours might be under create, pattern, circular pattern, and I've just pinned it to the top, pinned it to toolbar because I use it often. And let's go to, instead of pattern type feature components, let's go to features. Let's, for objects, select that last extrude we did. And our axes, we don't need to draw a new one, we can use our origin. Okay, it might look wacky at first. The default quantity is set to 3 right now on my machine. If I make that 2, you might not see anything. We can try some of these different patterns. It looks like optimized work for me. Sometimes you get some failures when you try these things. There's another reason I didn't fillet it before. We could have softened those edges and then done this pattern, but I find that when you start to fillet things and then pattern them, things just get disconnected and kind of lost in that translation. So now you can see the long edge is on this side, the short edge is here. So it just kind of gives it some, I don't know, makes it seem a little more organic without having to redraw it. So let's do our fillets. I'm gonna make sure I just have regular fillet. We can talk about rule fillet one day, but I think right now fillet's gonna be simpler for what we need to do. And I'm just gonna select these 2 edges. I have this tangent chain selected. That lets me just click anywhere on this edge and it's going to find anywhere it's tangent, it'll automatically connect it. So since we made our spline tangent, when we started off, it automatically connected that. Otherwise, if we didn't have tangent chain selected, we'd come in here and we'd click, and we'd click. It's just more clicking. So if you hit tangent chain, it'll automatically grab that. And we should be able to do this in just 4 clicks. This is one of the situations I would be careful grabbing this handle. Let's start off by just typing in some numbers. We know the thickness, or we know about how deep it is from here to here. That's gonna be half of 5/8. So we can say 5 divided by 8, divided by 5, or divided by 4, I'm sorry. Okay, but that seems to work perfectly. If we made it smaller, which we certainly could, I don't even care what decimal it is, but let's just say we can make it 0.1. And we end up with a flat somewhere in here. So we're transitioning this concave fillet, and then we have this flat portion, and then we have this convex fillet. I like to get away with as big of a fillet as possible, and I'm just thinking about how this was built. This isn't parametric the way we're typing it in. That's maybe like, there's a way to do it, but it's kind of advanced. We'd be using our parameters up here where we can define certain things kind of just numerically. We can talk about that in a later video if folks are interested. But we've got fillets on both sides. That looks great. Okay, let's look underneath the tub and let's think about reinforcing this. So under create in our features, in our solid features, there's a couple of these features we haven't talked about. We've done some extruding, revolving, sweeping, lofting. We've even done thread, we may have done hole, and we've done some pipe. But we haven't looked at rib or web. They're very specific to the plastics industry. If you look at anything that's been injection molded, or not anything, but a lot of things like a cover to like a device or something, if it's plastic, it's probably injection molded, and it's probably got these ribs and these webs underneath that form to keep that product thinner, so that when you cast it, you're not only using less material, but you don't get warpage or shrinkage as that material cools. So if it's kind of an even thickness everywhere, it lets you get away with having strength, but you don't have to make the thing solid. You save material and you kind of make a more accurate or precise form. So rib is when you have these overhangs, kind of create strength without making it solid. And a web is what we're thinking about today. We're going to add these kind of ribs that go down the back or the underside here. So what do we need to use this command? It's one of the simplest I can think of, and does a lot of things automatically. We could certainly extrude some sketches, but I'm going to instead just create a sketch. I started that sketch just on the base here, not necessarily the origin. Let's do it on the base just in case things change. I've clicked on that. Let's look at this straight on. Let's start our first rib, or first web. If you're having trouble seeing, I could turn off ambient occlusion, so we can see a little better down here. So we're still in our sketch. We've got our sketch palette active. I'm going to start a new line, and I'm going to draw it somewhere just between there and there. I just want to make sure this is perpendicular. So it's perpendicular here. These two lines are parallel. It's going straight across. We don't want it blocking any of our plumbing, so we want to make sure it's plenty far away from that side. And let's just go ahead and dimension this out. Let's call it an even 13 inches. Cool. I'm just going to draw one right now. Let's hit Finish Sketch, and let's go to Create, Web. I'm going to select this as the curve, and automatically it does a lot for us. It's very smart in that it looks, since we have an idea from the feature, it's kind of meant to just do one thing. It's looking for where we started our sketch and where the nearest object it is that it can extrude towards. Now, did it go all the way through? Let's see. No, it went ahead and stopped before it went to the other side of the surface. So exactly what we need. Let's make this the same thickness as our shelled tub, 5/8, and hit OK. And that's it. I'm going to save this. We've done some good work today. And let's mirror this. Or rather than mirror, let's pattern it. So let's take features as our pattern type, find that web on the history. Our direction, we can either set to this axis, but I'd rather do it off of the object itself. Just some line that's going this direction. And by default, it's going to start off with 3, and I can just click and drag to see how far those go. And you can set either the distance, how far from one object to the last object it goes, or you can change the spacing. So you can see with 3 objects, if we have a 30-inch total distance, the spaces between, there's 2 spaces between these objects, so they're 15 inches apart. We could change that to 13 just because that's an arbitrary number we used earlier. Let's go ahead and keep it 15. That seems pretty solid. And by default, it'll also give you quantity in the other direction. I found that you don't have to change this. It's not actually going to create 3 more things, but if you want to, you could just have 1. And we can hit OK. So there we have our ribs. And we've talked about filleting the inside because if we're making a pattern for this, or as it's being cast, it's good to have soft edges there. So you could select all these edges if you wanted, not the face but the edges, and it would probably take you a while. But sometimes selecting the edges is a little more particular, a little more accurate, because you can really get what you want and not have extra bits. Let's save some time and fillet these faces. You could do one like cavity at a time, but I'm going to go ahead and do all of the insides. So a lot fewer clicks than if we were selecting those edges. It's true. Okay. Let's make this, I think we had a 1/2 inch fillet for this part. Let's just make that 1/2 as well. It might not be the most optimal. Looks like we're having an issue with it. Okay, looks like a 1/4 is working. Ah, I see why. So because we selected those faces, it's also trying to fillet the top edge. We don't want that. So this might be a situation where we could either try a rule fillet and say between faces and features. And let's just try it over here before we click on all of creation. All of our creation. Okay, I don't need to select that face because there's no material that will touch it. Oh, let's have face features. Let's have the walls. And this part as they touch this part. Might be worth playing around with which of these you select in what order. Kind of get a different result there. But then we still want this edge. So we could try all edges. Okay, and it looks like that was the right recipe. Went ahead and took, we can see we've got all of those. I'm gonna go ahead and hit OK on this so we don't get a super crash. Okay, it's also taking that top edge. So let's see if there's anything we can do to keep that. Yeah, I think between faces and planes gives us the most control. So a rule fillet is a way to kind of think about what you're limiting this feature to. Whoops. So we can tell it to avoid that top edge. Now, if you're having trouble selecting things, hold down Control or I believe Command on a Mac, and that will let you continue to select. We can come back and fillet this later, I believe. Let's just try it. I'm going to go back to just regular fillet and select that edge. See if we can type in 0.5. So that works great. So I think the way to do this is the first step. Start with the walls for our faces features 1. Holding down Control to select multiple things. And face features 2. Looks like the floor is already selected for us. That's kind of interesting. That actually looks pretty helpful. Let's not forget these interior parts of the walls. I can tell Fusion's ready to call it quits. It's getting a little tired here. Didn't like that. Okay. Maybe we got to do one pocket at a time. Okay, I think you guys understand the filleting process. We can do that off camera at another time. And in the last portion of this, let's bring back our components. I'm going to hide our sketches, our construction plans. Let's bring back all of our pieces. And let's just talk about where we're at with the constraints of this object, what's locked down, what's able to still move, fly away. And then if we want to think about the important features on here that we want to move as if they would in the real world, just to kind of check the distance of things or just how things could look at different angles, or just for fun, let's add some mechanical joints. So I want to go back to where we ground everything. Remember we have this little thumbtack icon. It's kind of a red thumbtack icon next to all of our components. I think I even named that component ground, and I even said the date. So let's grab our history marker, and I'm going to delete all of these. Rather than, at this stage, you could also right-click and say unground, but notice it makes a new feature, which is just kind of more that the computer has to process, more that you have to process when you're looking back at history. So I'm going to select everything and hit delete, except for the tub, which I'm not sure which one that actually is there. Let's see. Okay, looks like the tub's still grounded. If you accidentally deleted that, you could just right click on the tub and hit ground again. Because the tub is really what is anchoring our drawing. Everything else is based off of that. Cool, I'm gonna go forward in time because we've got all these other components. It's probably best to do this kind of thing last. You could do it as you build. I think that's fine as well. But I want to do these things last. So I'm gonna make our joints visible. The joints that we made on our tap handle. I believe was just connecting the screw to the two nuts. I think that's all we did. When we imported this from the master website, we just made sure when we placed them, they were placed somewhere meaningful and not arbitrary. So we went ahead and made a rigid joint between the nut and the screw and this top finish nut and the screw. What we want to do now is we want this to rotate. We want this to be able to rotate. So how do we do that? Right now our handle's free. This is kind of its own little assembly right now, and then this is free. So let's make an as-built joint between the handle and this pivot. Let's go back to our tap handle base. We're gonna hide this because we just want to think about these pieces for now. An as-built joint component is the handle and the connector. Rigid is fine. We want it to not move. It's if these are tightened down or glued together. That's perfect. And now if we click and drag those, they're free to fly around. Now I'm going to bring our base back. And let's do another as-built joint. So an as-built joint rather than a joint is saying wherever these things are, since we kind of built these in conversation in the place that they're going to ultimately be, we're not changing or translating the location of something. So an as-built joint, I'm gonna start with that base. I'm gonna hide the base, it's still being used. And then the other component is going to be that rod, that connector, but we don't want a rigid joint. We want a revolute. So this is a motion joint. This gives us the ability to pivot around something. There's lots of different ones here, definitely worth exploring. What it does when we go from rigid to revolute is it's looking for a position. So what is the axis of rotation? I can hover over this rod because it's built from a circle. It's gonna automatically kind of suggest that that might be useful. We could also maybe use the nut, but I like the cylinder the best. So if you're just kind of hovering here, hold down Control or I think Command on a Mac, and you get these kind of coins. Whoa, we lost it. Okay, it's a little hard to see there. Can we see it here? Yeah, sort of. So I'm hovering over that cylinder and we get it to snap right there. Maybe we can see it from the top. Oh my goodness. Some of these objects are maybe obscuring our view, so let's hide some things. Okay, basically when we hold on Control, it's going to find a point on the cylinder that's relative to that axis. Let's just make it at the bottom. That's the simplest. Long story short there. So when we animate it, we might not see the right thing move, but let's not worry about that yet. Let's see these joints around the tub. Yeah, let's do it here. That's fine. So this is able to kind of fly around. I'm going to undo drag component, or you can hit revert. And let's make another as-built joint between the base and the tub. It's not going to be a revolute. We want this piece to be anchored and the other piece to pivot. So let's make that a rigid joint. If we click OK, now we should be able to turn that handle. That's pretty cool. This is why I like to do these things before I build them. If I'm going to build this object, this would be sad if we found out that that handle, somehow, if we really had a lot of water that could come out of this, we had a long kind of throw on that handle, it could potentially collide with the faucet. So we could change the position of this. It might not match the drawing. Maybe the drawing was kind of ambitious, but something about that just seems risky. So we could go back and find our sketch where we drew this. And maybe we could make this something short. Maybe we could make it 9 inches and hit finish sketch. It's going to rebuild it. It might take a little while on your computer as it's processing all this information. Okay, things got a little screwy, huh? Okay. Interesting. Let's see what that's all about. I think the first issue is our handle. Yeah, we changed position there because we wanted to make sure that since those aren't constrained, this might be a time to think about the constraints so that it would move, but we wanted to make sure that the top was over there. We could go ahead and do that, I guess. Project some geometry off of this dome. We can change that selection filter to the body, and it should give us a place where we can grab some center of that bell shape. Let's make all of this construction because we don't want that to change our revolve that this is ultimately going to be. And let's give this some kind of dimension. Works for me. I'm also going to dimension the length of this. So we're just constraining this. That means they can't change so much. Now our spline can certainly change. We could change the shape of this thing. You know, that's not constrained. We also want to constrain how far up and down it can go. So let's one more mini D on the keyboard to do this. Dimension out. You can make these better numbers than these, but I think they're fine. Better is probably not the word, but more round numbers. Finish sketch. See when we rebuild here what is going to happen. Still a little strange. So let's go back to where we made our tap handle pivot point. So this has to do with how we built that construction plane. So if we make that visible, this was tangent at a point. So tangent and then that point. That point is now no longer centered for some reason. Maybe what we could do is we could make this sketch visible. That's very interesting. So it looks like the problem started from our tap handle base sketch changed. This is what happened. Aha, because we no longer have that bell shape. So again, hard to constrain splines. We could try to dimension these points out. Okay, now we're looking a little better. So it looks like when we did that work we did before, we're just kind of problem solving here. This is how this goes a lot of times. That work we did before with that midpoint is gone now. So if we click, and we might just have to delete this sketch and start over. I'm going to try clicking on that point, hit and delete. Looks like not going to do it. So let's make that just one more time. Make it construction. You can hit X on the keyboard or go over here and click construction with that selected. And I'm going to dimension this and dimension the height. Just cross our fingers. We can hide that. I'm going to drag this just a little bit forward in time. Okay, it looks better. It's a little better. So we can bring this up some. Oh, excuse me. Just make that look like it's really kind of biting in there. Let's also make this one come down a little more. This could be a time to make a counterbore on this handle, but let's go ahead and figure out our joints and mirroring it. Because right now we've got this piece over here. All of those changes updated when we mirrored, all of those movements and things. But when we go to the end, after the point where it's going to take a second to compute all those changes, with our swinging handle, let's see if it clears. This is kind of the moment of truth. Okay, we got plenty of room. We could probably even come back a little closer. We won't tempt fate today. We can try it afterwards. But we can see that's clearly flexible. With a little bit of tuning and a little bit of rebuilding, trial and error, you can make this thing a pretty solid model where you can change those dimensions. Should be fine. Okay, we're at 250. I'm going to try to wrap this up quickly, but show little things that can go wrong. So we made these over here after we mirrored, so that maybe is why we're not getting these joints. Okay, these two, nothing is connected anymore. So let's go back to revert. I'm going to delete this mirror here. It shouldn't affect anything on the timeline because that isn't referencing anything else. I'm going to hide that tap handle profile. Okay, we're all the way at the end, making sure I'm just clicking forward in time. And let's do mirror, components. Scroll down here, we've got our big old mess of components. And we can click on all of the tap pieces. So we've got 5 pieces there, 5. Our mirror plane. We can make the origin or our long mid plane. Click OK. So notice we don't have any of those joints. Those joints didn't pattern for some reason. Something that Fusion doesn't make super easy, it turns out, or as straightforward. We can do it. It's just going to take a little bit of cleverness. We also know that we want it to kind of organize our browser a little bit. So I'm going to right click, delete this mirror. We can come back to it. When we're at the end of our timeline here, let's make this a little more organized. We're going to make this into a subassembly. We can hide some things. We can hide some things. Let's go to right click at our top here where it says tub demo, whatever the name of your file is. It's going to be the uppermost component, and make new component. Let's rename this. Rename. Maybe we could just click on that one more time and say we should be able now to drag each of these pieces into that tap handle subassembly. To prove that they're together, we can try the eyeball and see if they all go away. And notice this icon change. I'll go back in time. So right now, not the eyeball, this icon changed from tap handle, where it's got just this cube like the rest of them. And we go forward in time, this icon now looks a lot like this icon. So it's an assembly within an assembly. Because since this component, this whole drawing is one assembly of all these different bodies and components and geometry, canvases, joints, all these things. So the joints also traveled with that into this subassembly. That's encouraging. Notice what happened to our history. Did we end up losing all of our work before? No reason to panic yet. This radio button is next to our tap handle assembly. It's the active component. If we want to go back and make our tub assembly, the active component, now we get all of our history back. Now, any features that built this before we turn that into its own subassembly, these are still going to be on the timeline when it's in this mode, because we haven't made it into a subassembly until the end, which, depending on how you're working, might make more or less sense. Here, it's gonna work out fine. We got these features. Turning them into a subassembly, it looks like a cut and paste, but it's drag and drop. It's fine. Nothing's been really changed permanently. That's what we always want to make sure. So let's try our mirror command now, after all that work. So now we should just be able to select, when we have pattern type components, just our tap handle assembly, and our mirror plane. Let's just take that origin. We can grab it. Looks like we can't grab it. So let's take our long mid plane. Get a nice little preview and click OK. I'm not seeing any joint icons. If we click and drag, the whole thing moves. Okay, it looks like those joints didn't translate over when we mirrored it. Let's open this and just see where we have our tap handle assembly mirror. No joints. Okay, that's frustrating. I think Fusion should fix that. But there's a way to do this. Okay, let's see, we got 5 minutes. Let's pattern this in a different way that will still mirror it. Stay with me. It's going to be kind of like what we did with our cutouts here. Instead of mirroring it, we did a circular pattern around a central axis. So if we go ahead and try that, make our circular pattern type is components, select our tap handle assembly. Let's just do it the same way we did it with our pretty cutout feature. And I'm starting to think this isn't going to work out so well. This could be a conceptual tub where you have to, run to either side of the tub to grab the hot water or cold water. But it looks like no matter how many we add, we're really just not getting an equidistant mirror between this and that. So what this means is we're going to have to change our pivot point, our axis of rotation that we're rotating around. This is kind of a beautiful thing, though. I kind of don't want to get rid of this now. Let's hit cancel, though. So let's establish the axis of rotation that we want for our tap handles relative to the tub. So let's take this faucet and just hide it for the moment. Let's look at the top. And what I want to do is start a sketch on top of the tub. It could really be on any plane that's parallel to this plane, but we're starting a sketch, and I'm going to click on Create, Project Include, or P on the keyboard. And I'm going to click on our selection filter, just the specified entity, select this bottom edge of our bell shape, click OK. And I'm going to hide our tap handle assembly. And what we want to do is we want to mirror this shape over to this side. So let's find our origin, and let's take this and just draw a line all the way to the top, make that construction geometry. Selecting it, select construction. And now we're going to, with our sketch active, go to create mirror. And let's select one object. That's going to be the circle. And our mirror line over here, we're going to mirror that sketch to the other side. And click OK. Okay, all of this really, we can make construction geometry. Oops. Now we're going to take a line between these 2 points. That's all there is. And I'm going to make a point at this intersection. Okay, so we've established our pivot point. So let's bring our tap handle assembly back, and let's see if we can get away with this. So mirror plane, or excuse me, we're not doing a mirror, we're doing a circular pattern, that's right. Select component, tap handle assembly, our axis. It's unfortunately not going to let us select that point as an axis. It's going to take either of these lines, which again is looking very strange. So unfortunately, we need to make a new plane here. Let's go to construct, plane at angle. You can select here, or actually we don't need a plane. We don't need a new plane. Let's take our mid plane, construction, along mid plane, create new sketch. I pre-selected that mid plane and then went to create new sketch. So we should be drawing along this mirror line. Let's L on the keyboard, start a new line. I'm just going to draw a vertical line somewhere. If it's not vertical, we can, with the constraints, click on horizontal, vertical, click on our line, snaps to attention. I'm going to take this bottom point and drag it. And it's not connecting with that point automatically, so we need to project this point. This is a lot of trouble to mirror this thing. Sometimes it can pay off though. So I'm going to select that point, click OK, and I'm going to click and drag until those snap, or you could go to coincident, click one point, click the other point. Actually, let's not finish that yet. Let's just dimension this. so that if something changes, it doesn't end up in the sky or going the other direction, just so we can find it. Let's call that 5 inches, and I'm going to, just a random number there, it was not important. Let's name this. We've got a lot of sketches we haven't named recently. Let's call it rib. So this is the axis we're going to use to pattern. So our circular pattern, one more time, let's go to components, scroll down to find our tap handle assembly with axis. We're going to make this 2 handles, hot and cold. Click OK. Let's hide these sketches, close our sketch drawer, bring our faucet back. So now we've got, this thing still is wiggling, so what we need to do is ground that. Go into our tap handle assembly number 2. It doesn't say mirror anymore, it says number 2. And let's take this base and ground. Or we could take an as-built joint and select this piece and this piece. And now we should have a rotatable handle on both sides. And all of the pieces are stuck together like glue. Some of these pieces you probably want to think about as just a as-built rigid joint. Okay, that pipe we don't want moving. This faucet we definitely don't want moving. That would be disastrous. This cap we probably don't want moving. If we go down here, the drain plug we do probably want movable, but we probably want this grate to stay there. So let's see what we can do with this drain plug. Let's do an as-built joint between the drain plug. Let's hide the tub. Let's hide pipe. And let's make the drain plug and the grate in conversation. Let's turn this into a motion, and let's make this, you could have it a revolute, but I think what we want is, let's try, seems to take some experimentation. Let's try a slider. In this position, let's make it that cylinder. Okay, and there we go. This might really be rotational and sliding because it's probably actually threaded. As you screw or unscrew, the stopper goes up or down. If we open up motion, we get the option to change that type again, but also the axis. So you could have it slide this way, you could have it slide that way. You could have it slide against the z-axis, or custom. We'd have to actually have a line there. Oh, okay, if we select custom, then select that cylinder. I like that more. It's really kind of speaking about the part. You know, I'm a fan of that. So let's click OK. Now, this is kind of unrealistic because it's crashing in there. That's not great. Let's bring our tub body back. I'm going to save this. And if we go to assembly, we can do something called enable contact sets. I'm going to enable that. And now we can see, let's see, new contact set. Let's make it between these 2 pieces. So now it's keeping me from pushing that any further down, but I can raise it all the way up. So contact set is actually Fusion detecting if there's collision between objects. Now this is working pretty well here because it's really just 2 things that it's calculating the interference between. I can hear my computer's fan kind of going, even for this simple kind of relationship between these 2. But a contact set is just looking for collisions, and you can make many of them, you can name them, you can turn them on and off. I'm just going to disable that contact because we want to do this a different way. Let's find that joint. And you know what, we could even make this a sub-assembly. We can still do that afterwards. And let's come find that. It's the slider. And we know it's that one because if we click on it, it highlights in blue where it actually is on the drawing. Let's right click and go to Edit Joint Limits. So this animate, this is going to show us how far it can go up and down. Let's give it some dimensions. So right now it looks like it can go down, it can't go any farther up. maximum. Let's just start with some dimensions and see what happens. So it looks like if we make these the same integer or the same value, it can't go anywhere. So I'm just kind of plugging some numbers in and seeing what happens. It looks like the maximum is, if I set that to 0, it's going to keep it from going too far down, but maybe this is too far up. If we make this a positive number. So yeah, for some reason this is negative. It's kind of weird, but let's make that smaller. Okay, that's kind of cute. There it is, closed, open, closed, open. 0 is where we kind of built it, the construction plane there. And I think we have a fully locked down sketch. All the components have some kind of joint. They have some kind of connection to each other. Super cool. We did a lot of different things today. We made some kind of beautification with some interesting construction geometry to make that happen, to keep smooth edges. You know, you could also try other things besides an extrude. It was kind of a simple way to do it. You could try lofting. You could try, you know, some surfacing. We haven't talked about surfacing yet, but you can create some complex forms. I did a video on that on Wednesday. I was helping out a friend for a project. You can see that on the channel. And then we made some reinforcement, some ribs down here. And then we worked on some mechanical joints and had Fusion translate those mechanical joints through a sub-assembly as we patterned it rather than mirrored it to have those move through that pattern. Okay, next Monday, I think we're going to finish this up. Let's do some fun, kind of weird stuff. Let's think about the water that's coming in here. We'll maybe try some sculpting. And then let's talk about rendering. Let's talk about making this thing more photorealistic with the rendering workspace. And we can talk about doing that on your computer and leveraging the cloud that Fusion offers students and educators, the computing power on another machine somewhere in the world. Okay, thank you all for joining me. Have a good weekend. Looking forward to the next one.